Hello and welcome back, students, for Math 45. This is your instructor, Cindy Enrique, and we're going to continue on page 36. So this is section 5.6, part B, and we're still talking about these rational functions. I just couldn't fit this in the last video. Okay, so here we go. It says, remember how to solve rational inequalities. We find the boundary points. We determine when the inequality is undefined, and then we use the boundary points and use the test point method, and then we write the answer in interval notation. So let's go ahead and start off with this problem. So it says solve for this rational expression for when it's less than or equal to 0. So I know that whenever I have less than or equal to 0, then that really tells me that I should be looking at negative intervals. Okay, so I know I'm going to be looking at negative intervals, and this is our original equation. So step number 1, we are going to find our boundary points. So the way we're going to be finding our boundary points are going to be two different ways. The first one is we're going to set our numerator equal to 0. And the second thing we're going to do is we're going to set our denominator equal to 0 as well. When we set the numerator to 0 and our denominator to 0, that gives us our boundary points. So let's start with the numerator. So with our numerator, we have this x squared plus x minus 12, and we're setting it equal to 0. So when we do that, we can go ahead and we can factor. So when we factor, you can do the AC method if that's what you like. I know that two numbers that multiply to 12 is 4 and 3, and to get a positive 1, I should have a positive 4 and a negative 3. So that tells me that x plus 4 is equal to 0, so x is equal to a negative 4. I also have x minus 3 is equal to 0, so x is equal to a positive 3. So I have my boundary points. I have negative 4 and negative 3. Now I'm going to look at my denominator. Looking at the denominator, I'm going to set that equal to 0. So my denominator, remember I had an x squared minus a 4x minus 12. So I'm setting that equal to 0. Again, I can factor this. But because my middle term is different, I know I'm going to be factoring it slightly different. So I'm going to have x 4, no, not 4, but 6 and 2 gives me 12, and a negative 6 and a positive 2 will give me a negative 4. So x minus 6 is equal to 0, so x is equal to 6. X plus 2 is equal to 0, so x is equal to negative 2. So now I have all of my boundary points. I have my critical factors. So boundary points. So for my boundary points, I have x is equal to negative 4, x is equal to positive 3, x is equal to 6, and x is equal to a negative 2. So it looks like I'm going to have 4 different boundary points, and that's okay. So after this, what I want to do is I want to put them all on a graph, the number line. So here are my points. It looks like I have negative 4, I have negative 2, positive 3, and positive 6. So I'm just listing them all on my number line. So now what I have to do is I'm going to pick some values and plug it into my equation. So here we go. Let's say I'm going to try a couple of things here. Trying to figure out what color I want. Okay, over here. So let's pick a number that lives over here. Let's say x is equal to a -5. That means I'm going to plug -5 into my original equation. So I'm going to have a -5 squared plus -5 minus 12 all over -5 squared minus 4 times -5 minus 12. So what I'm doing is I'm letting x equal to -5 into my original equation. I don't care so much what the exact answer is going to be. I just want to know whether or not it's positive or negative. So when I plug that into my calculator, I get, when I plug it in, it's going to be positive. Okay? All right. So now I'm going to do it again for the next interval. So now we're going to do it again. So now over here, let's pick a number that lives between -4 and -2. So I don't know, what if we try x is equal to -3? So I'm going to plug -3 into my original equation. So -3 squared plus -3 minus 12 all over -3 squared minus 4 times -3 minus 12. When I plug that into my calculator, I get that it's going to be negative. And so I'm going to keep doing this. I'm going to keep plugging in these values for my intervals. So let's see over here, I don't know, between -2 and 3, maybe x is equal to 0 might be a good one. So here, when I plug that in, I'm going to get a positive. And I don't know, if we try x is equal to, I don't know, it doesn't matter, 4. I'm actually going to get a negative. And over here, let's say x is equal to a 7. So that's going to be positive. So remember, from the very beginning, we wanted to make sure we got all of our negative intervals. So if I'm looking for my negative intervals, that's here and here. So I can firmly say what my answer is going to be. I can say that my answer for interval notation is going to be the following. It goes between -4. Ooh, and I have to be careful here. I remember, before I write this, that the denominator here, my denominator, that's going to give me division by 0. So that was at x is equal to +6. So I have to be careful here. And x is equal to -2. So that has to be careful here. So at -4, I'm going to have a bracket. But at -2, it's going to be a parentheses because it's part of my denominator, and the denominator cannot equal to 0 because if I have, let's say, 5 divided by 0, that's going to be my undefined. So I cannot include 0 from the denominator. And then it's union, the next piece. So I have a 3. That's fine. Ooh, and at 6, I have to be careful. At 6, I have to be careful because that boundary point came from the denominator, and the denominator cannot equal to 0 because we cannot have division by 0, so it's going to have to be a parentheses. Okay? All right. And so that is going to be my final answer that I want. And that concludes the end of section 5.6. Thank you for listening.